We've talked about indeterminate forms that look like 0 over 0 and infinity over infinity, but these are not the only indeterminate forms that we have. If we have something like 0 times infinity, we can't necessarily assume that that's going to be either 0 or infinity. Infinity minus infinity is another one that we just don't really know what that looks like. These other three right here are also indeterminate forms, 1 to the infinity power, 0 to the 0 power, and infinity to the 0 power. So these are all different indeterminate forms. L'Hopital's rule tells us how to deal with these first two. The other 5 that we have right here, it's sort of up to us. Now there are workarounds so that we can use L'Hopital's rule. So we're going to look at these first 2 here in this video, and then we'll come back and talk about the last 3 in the next video. So we're going to look at a couple of these. Here I have the limit as x approaches infinity of x squared times sine of 1 over 4x squared. So here, the hint that we're going to use, we're eventually going to divide by the reciprocal, but hold on to that thought here. If I try to take the limit right now, I would say limit, and actually here, let's just do this. If I look at the limit of x squared as x approaches infinity, that piece goes to infinity. Sine of, and let me circle it so that we can see it, sine of 1 over 4x squared. If I look at just the inside part right here, if I look at 1 over 4x squared, as x approaches infinity, that's going to go to 0. So I really have infinity times sine of 0. I have infinity times 0. So this is another indeterminate form. We have 0 times infinity. I can't necessarily assume that that's going to be 0 or infinity because infinity is not a real number. It doesn't play by the same rules as all the other real numbers. So here is my hint. This is what we're going to try in this case. We are going to instead divide by the reciprocal because I know that I can rewrite this. So I'm going to actually just take the same limit statement, limit as x approaches infinity. If I were to take this x squared here, I'm going to rewrite this as sine of 1 over 4x squared, and I'm going to divide by the reciprocal of x squared. So I'm going to divide by the reciprocal of x squared, which would be 1 over x squared. So I'm rewriting this in a very particular way. If you don't see how these two are equal, take a moment and think about, okay, if we were to multiply by the reciprocal here, multiply both sides by x squared, I would have exactly what we started with. So my goal here is to try and rewrite this limit in a way that gives me an indeterminate form that L'Hopital's rule applies, either 0 over 0 or infinity over infinity. So I'm just trying to see if we can rewrite this in order to force L'Hopital's rule to work. So I've rewritten this expression now. Let's try looking at the limit in this case. So if I look at sine of 1 over 4x squared, again, if we just look at what the inside part here does, 1 over 4x squared, I know that that's going to go to 0, so this approaches sine of 0. And 1 over x squared, if I look at that as x approaches infinity, I know that this is going to approach 0. Sine of 0, that goes to 0, so I end up with 0 over 0. This is something that we can now use L'Hopital's rule with. Again, we couldn't use it before when we had infinity times 0, but if we rewrite this expression in a way that looks like 0 over 0, then yeah, absolutely, we can use L'Hopital's rule here. So here I am going to rewrite this a little bit just because I think this is going to be a little bit tricky to work with. Notice here that I can rewrite my numerator as sine of 1/4 times x to the minus 2, and my denominator I'm going to rewrite as x to the minus 2, just so that it's easier to take the derivative of the numerator and take the derivative of the denominator. Otherwise, we're stuck using the quotient rule and the chain rule here. So that's just trying to hopefully make our lives a little bit easier coming up in this next step, where we apply L'Hopital's rule, and I'm going to be thinking about, okay, derivative of my numerator, derivative of my denominator. In my numerator, I am going to have a chain rule, so derivative of sine would be cosine of 1/4 x to the minus 2 power, and then I need to multiply that by the derivative of my inside part, so the derivative of 1/4 x to the minus 2, that would be negative 2/4 times x, subtract 1 from my power, now to the negative 3. Divided by, in my denominator, here I just want the derivative of x to the minus 2. I can just use my power rule. Here I'll have negative 2x to the negative 3 power. And of course the limit statement, that comes down as well. So limit as x approaches infinity of this new statement. And hopefully we should see that we can cancel a few things here. I see x to the minus 3, I see x to the minus 3. Hey, look at that. Those two will cancel. Let's rewrite some of this. I'm going to just simplify this and clean it up here. So we have limit as x approaches infinity. I'm going to rewrite this as cosine of 1/4x squared. Once again, I think that's going to be easier to work with, times negative 2/4. And here, if I want to get rid of this negative 2 in the denominator, I'm just going to multiply by the reciprocal over negative 2 times 1/2. So if I multiply by 1/2, here we can cancel the negative signs and cancel the 2's. So okay, let's simplify it just a little bit more. I really have, this is just 1/4, so I can rewrite this as limit as x approaches infinity, 1/4 times cosine of 1/4x squared. So up until this point, here I did my derivative, and then after that it was really just a lot of simplifying. So okay, now I'm going to look at the result, 1/4. Again, if I look at what does the inside part of this do as x approaches infinity? Well, 1/4x squared, that is going to approach 0. So 1/4 times cosine of 0. But I know that cosine of 0, that's just 1. So 1/4 times 1 gives me 1/4. So here is my limit. So we're going to talk about a couple of different tricks that we can use here, and this is the first one here. If we're multiplying, if we have something that ends up with infinity times 0, we can use this trick of dividing by the reciprocal to help us rewrite this in a way that we can use L'Hopital's rule. Because remember, we can only use L'Hopital's rule if it's infinity over infinity or 0 over 0. So in this case, it didn't work. We had to rewrite it in a way that made it a little bit easier for us to apply that rule.